So I'm going to tell you about the Gravitational Wave Open Science Center, which we call GWOSC. It's a fun word to say. The subtitle that's hidden here is how you can get the data yourself. Of course, GWOSC and the Open Data Science Center is not made of concrete and steel, mirrors and lasers, smoke and mirrors, or any of that sort of stuff. It does have an address. The address is on the web, and I've got it up here on the page. This is the home page for the website. And what you can get here is more than just the strain data that you've heard talks about, or the data quality, or the hardware injections that you've heard about. But there's also a plethora of other things, documentation, tutorials. I won't go into all of it, but there's a lot of information there for you to get. And I think an important thing to get clear up front is what is open data. When we say we're putting this data out, we mean that the data can be freely used, reused, redistributed by anyone, subject only to, at most, the requirement that attribution and you share alike. All of the guidelines for our releasing this open data are captured in the LIGO Data Management Plan. This is the URL. Anyone can read it publicly. Primarily, though, there's two types of data that we release. We release what we call bulk data, but it's the comprehensive data associated with the full observing run. That has a release schedule that is in blocks of 6 months of data with a latency of 18 months of data from the end of the acquisition of that observing block. That's the way it stands now. Hopefully that will change in the future. We also have started, I think Jess mentioned this, we started our third observing run on April 1st of this year. So based on this formula, the schedule for releasing the data from 03 for that first 6-month block would be in April of 2021. In addition, we release about 1 hour of data associated with any events that get published. So if there's a publication released, at the time of the publication, we would release about an hour around that data. And of course, any of these releases, as I've said, are supplemented by lots and lots of other information that are really useful. The data sets themselves are time series. That's just the nature of how we gather our data. And we distribute it in several different formats, HDF5, gravitational wave frame format, the GWF, and for the events only as gzip ASCII files. So you've seen these already. I won't go into too much detail, but the data is being collected from these detectors. At this point in time, we have data available to the public from the S5 and S6 science runs of initial LIGO, and we also have the 01 and the 02 advanced LIGO data set. With the 02 data set, we've also included Virgo now, so you can get their data as well. Here's just a little table showing you the start and stop times of these particular runs. The detectors that are involved, H1 is Hanford 1, 2. How many people knew that there used to be 2 detectors at Hanford? I see a hand that went up. Now we only have 1, Livingston and Virgo. These little timelines, these are charts that I'll get into a little bit more, but they show you when there's good data, and you can see the little dropouts that Jess was talking about in them. So the technology that goes into us making this public is a little bit more advanced than an anonymous FTP site. I'm not going to go into all the tools, but this is sort of the sketch of what sorts of pieces that come together to make it possible for us to distribute the data, to do development, to reach out to the public, and to provide feedback, interactive feedback through a ticketing system and response system. What you won't see on this chart are high-performance computing resources, just to make that clear. We don't have Siri or Alexa or anything like that, so you have to use a mouse and point and click. But the main navigational features of the website are at the top here. We group things into 4 categories: data, software, online status, and about GWOSC. The timelines that I mentioned that tell you when and what data are available, they give you some characterization of the data quality, tell you if there's any hardware injections. And to get to that, you just go to timelines here. This pops up a form where you can fill out or select pre-constructed timelines, but let's go to the form. If I'm interested in O2, I click on O2. I get a set of flags that I can select from. I select the flags I'm interested in. At the bottom is a URL. I go there and I get the timelines. And this is an interactive page. You can zoom in and out on it. The strain data itself is under the data as well. You go to strain data. That takes you to a page that lists all the different strain data sets. If I'm interested in the O2 16 kilohertz, that's 16,000 samples a second. I click on that. I go to a form where I can, it's pre-populated with the dates, but I can change that if I want to. I pick the interferometer that I want to. I click continue, and I get a list of all the data sets. Each one of these is a 4096 second long file. It tells you the start time, what percentage of the data is good. You have a choice of selecting HDF5 or the frame format that I mentioned, and you click on that and you get to download it. But clicking on each one of these files, if you're interested in a lot of data, will be painful. Trust me. So we also use something called CERN VMFS to distribute the data in wholesale. If you click on this link, it gives you instructions for installing the client, the configuration for the client, and an example of what you should see once you've configured it and it's running right. This gives you, on your computer, your laptop, a virtual file system that looks like any other NFS-mounted file system that accesses the data. The data is actually hosted by the Open Science Grid. I think it's in Illinois, but anyone can do this, and they can see the full 22 terabytes of data through that mechanism. We now have a transient catalog, gravitational wave transient catalog. Last week, I think the publisher accepted the paper in final form for publication, so it should be out soon. But the data has been on our website for a very long time. In fact, since the preprint went onto the archive. So since then, you've been able to get the data. And if you want to go and get it, you just do the same sort of thing. You land on this table that has some of the physical parameters of each of the events. If you select one of the events, you'll see the physical parameters, and you'll see the list of files that you can download. Same thing as before. You click on one of those, you download it. But what you'll find on many of our pages, and I'm sure you can't read that, but it says that this data set's available as a JSON file. And so if I click on that, you can download a JSON file that has the URLs and the metadata about all of those files on that page. There's a lot more information than just the data sets. I've mentioned some of that, but let's just go through those quickly. If you're interested in the current detector status, you click on that. You go to, if you want to see what today's summary pages is, this will give you a summary of what the detector behavior is today. The operating state, sensitivity, estimated range to binary neutron stars. We have pages with long lists of software that you can download to work with our data. There are sets of tutorials. This is multimedia. There are lectures that are recorded. There are all sorts of formats of tutorials here, and I recommend anyone that wants to get started to look at that. We also get feedback from the people that use our data. If you click on projects, you'll get a list from the user community of publications and some description of their projects that you can get to from this page. And then the other interesting thing is that so far on an annual basis, we host a workshop. And it's typically attended by about 60 people. The last one was held in April of this year in Paris, France. The one before that was here at Caltech. I think next year the plan is India, but it's not definite yet. And so you can attend these week-long workshops and get hands-on experience and some guidance from the experts. So I'm probably running out of time, so let me close by just saying that our current focus is on releasing the events in the form of catalogs and getting the bulk data out. We're still learning about catalogs. It's a very new thing to us. So this may evolve. It may look a little bit different in the future from what it is now. I've given you an idea of when the first 6 months of 03 will be out. The specifics of all of this is decided by the collaboration. So will we release more data? Will we release seismic data or something like that? That's up to the collaboration to decide. Will we reduce the latency between releasing? Collaboration decides. So hopefully things will get bigger and better into the future. Everyone that works with technology knows that this is an evolving set of tools that we use, so we have to maintain it, keep it going, find replacement for things that don't work anymore. But the big problem for us is as our sensitivity doubles, our rates go up by 10, and we've got a scaling problem. So we got to get this data out to you guys. And if it's 100 times more data than it was in the last run, that's 100 times more work for us. And we will continue to host these workshops, and tutorials will upgrade as our understanding of the data and the detectors is improved as well. So in closing, I'll leave you the address again and say thank you.